So the reason that you were introduced to remainder theorem previously is so that we can use it for this new theorem called factor theorem. And factor theorem is the more important of the two of them because it actually allows us to do something with the information from the remainder theorem. But before we get into it, let's just refresh our memory on sort of where we're at in our learning. You can recall from Unit 1 that graphing polynomial functions is super easy in factored form. Factored form gave us the x-intercepts, and then we could see the degree of those x-intercepts, so we would have an idea for how it crossed the x-axis. You could very quickly see as well what the end behavior was, and so it was really easy to put together a quick sketch of a polynomial function once it was in factored form. Previously to the learning in grade 10 and grade 11, and as a part of the review for this course, we looked at a lot of the different factoring strategies that you had already seen. Simple trinomial, complex trinomial, difference of squares, and perfect square trinomial. All of those deal with factoring polynomials of degree 2 or quadratics, okay? And this is always a good baseline. You should always check first to see if you can factor using these strategies. These are going to be quicker than any type of higher level factoring that we're going to be doing today and for the remainder of this course. Always rely on your basics. Go back to your roots. However, sometimes that's not possible, and that's where factor theorem comes into play. You'll also remember that the remainder theorem allows us to quickly check what the remainder is. We saw that the remainder is equal to our function at that point. And previously we mentioned this is where it all sort of comes together, and the key sentence in all of this is that if a remainder is 0, that means that the divisor is a factor of the polynomial function because it divides easily. We are able to literally factor it out simply by quickly checking what the remainder is. Okay, so the question we have here, how can we determine the divisors that are factors of any given polynomial? And that's what our sort of goal is with factor theorem today. Let's do one example where we have a leading coefficient of 1. This will give you the gist of how to complete factor theorem and how factor theorem is useful. And then we're going to do a second example where the coefficient is not 1. So we're given the expression factor x cubed minus 4x plus 3. Okay. Very first thing, simple, we're going to set our expression equal to f of x. We're going to make it a function. This allows us to employ remainder theorem. From here, we're going to use the constant term, okay? That's our 3 at the end there, in order to find possible p-values that we can substitute into f of x. And the question you should be asking yourself is, what multiplies to p? Okay, so we're going to see here, we need to check what are our factors of 3. 1 goes into 3, and 3 goes into 3. But so does negative 1, and so does negative 3. So all of our factors, whenever we're doing this, are always going to be this little plus minus symbol. If you haven't seen that before, it's literally a little plus sign on top of a minus sign, which indicates that both positive and negative are an option. Think about it. In order to get positive 3, I could do negative 1 times negative 3, right? That's the tricky way of doing it, but I could do that. Here are my possible p-values. You'll remember that the p takes the form when we actually put it in, and we write it as a divisor of x minus p. So we've determined what our factors are, what the possibilities are, and there are 4 different possibilities here: positive 1, negative 1, positive 3, negative 3. We're now going to use the remainder theorem to guess and check each one to see if it's a factor, okay? Remember, in order to have it be a factor, we need the remainder to be 0. And my advice to you is just to start with the lowest numbers first because you can do the math in your head pretty quickly. So let's start with 1. Okay, let's check when x is 1, or we would write x minus 1 is the official divisor. I'm literally going to put it in my equation. F of 1 is 1 cubed minus 4 times 1 plus 3. 1 minus 4 plus 3 is 0. Bingo! Jackpot. That is what we want. The remainder is 0. Let's write this out here. Remainder is 0. That means, therefore, that x minus 1 is a factor of our function f of x. Yay! Remember, the negative 1 is opposite than the number we actually put in because it's how we're writing it in the brackets there. Okay, we've done that. We hit the lottery on our first attempt here. If 1 had not worked, I would have then tried -1 and then +3 and then -3. And eventually you will get 1 because your teacher is not a cruel human being. Okay. Next step. So we've determined that x minus 1 is a factor of f of x. So now we are actually going to do the division. And so I'm going to use synthetic division because it is the faster method. It doesn't matter if you want to use long if you want. It's just longer. Okay, so our factor once again is 1. And let's find our polynomial again. Okay, so our leading coefficient is 1. Then we don't have an x squared term, so I need to put down a 0. We do have an x term with the coefficient of -4, and then our constant term is 3. Okay, let's do this division here. I bring down my 1, multiply across 1, add down 1. Multiply across 1, add down -3, multiply across -3, add down 0. Bingo! We're all good. And so I've included this little sort of thought bubble to the right here. At this stage, how would you know if we had messed up somewhere along the way? Well, we need the remainder to be 0, and recall that that last digit is the remainder there, okay? If this number if it's not 0, you've done something wrong. Maybe you've divided incorrectly. Maybe you did your math incorrectly when you were checking, guessing and checking in stage number 3. But you need to check if there's an issue, stop everything. Let's go back and take a look. Okay. Let's actually write this out now. So our factored form of our polynomial, so our polynomial was x cubed minus 4x plus 3. Our divisor that we just found was x minus 1, and again, I got that over here and from before. And now I'm going to multiply it by my quotient. So that's x squared plus x minus 3. Awesome. We are now at the stage where the result is a quadratic, and so time to activate that muscle memory and think to yourself, simple trinomial factoring, complex trinomial factoring, perfect square, difference of squares. Can I factor my quotient further? So the quotient, again, the answer we got was x squared plus x minus 3. Can we factor it further? Are there two numbers that add to 1 and multiply to -3? The answer is no. No, we cannot factor further. So we're done. Okay. Our last step here is to write out that multiplication statement to continue, which I had already done previously, but I'll rewrite it down here. x minus 1 times x squared plus x minus 3. If you were able to continue factoring, you would continue factoring, and then you would, instead of writing this quotient, you'd actually write the two brackets that it was a factor of. Okay? Let's do another example, this one with a longer trinomial. So, very first step, we set our expression equal to f of x. Awesome. Okay, now we're going to determine what are our possible p-values. And so we look at all the different factors of 24. 1, 2, 3, 4, 6, 8, 12, 24, and all of these could either be positive or negative. Here we go. That's a lot of different numbers to check. Okay, let's check our first one. Let's just check 1. F of 1 will be 1 cubed minus 1 squared minus 14 times 1 plus 24. So that's 1 minus 14 plus 24. I can already tell this isn't going to be 0. It'll be 10. Nope. We need one that has a 0. Okay, let's check negative 1. No, you know what? I'm going to check 2. Two cubed minus 2 squared minus 14 times 2 plus 24. 2 cubed is 8 minus 4 minus 24 plus 24. Nope. 14 times 2 is 28. This looks promising. 8 minus 4 is 4, minus 28 is negative 24, plus 24 is 0. Yay! X minus 2 is our divisor. Okay. Let's go ahead and divide now. So my p-value is 2, and I'll write out my coefficients. 1, negative 1, negative 14, 24. Bring down the 1, multiply across. Add down, multiply across. Add down, multiply across. Add down. The remainder is 0. We have done our job correctly. X minus 2 is indeed a factor. And so our factored form, and I'm just going to write the factored form, is x minus 2 times x squared plus x minus 12. And then we ask ourselves, can we factor our quotient even further? Not using factor theorem, using your regular trinomial factoring strategies. The answer is yes, we can. Two numbers that add to 1 and multiply to negative 12 are positive 4 and negative 3. Positive 4 and negative 3 add to 1, and they multiply to negative 12. So I can factor this further to be x plus 4, x minus 3. So this factored form is a much nicer thing to work with instead of this guy over here, eh? We can clearly see the x-intercepts. We can clearly see the degree. We would be able to sketch this super easily. Okay. All right, let's do another. This is going to be a longer one because we do have a degree of 4, so we're likely going to have to do this twice. First things first, set at f of x is equal to x to the 4 plus 3x cubed minus 7x squared minus 27x minus 18. All right, possible p-values. For 18, include 1, 2, 3, 6, 9, and 18. Perfect. And all of these can be positive or they could be negative. Okay. Let's check our work. Let's see which one is going to work. Let's do x is 1. Mm. 1 to the power of 4 plus 3 times 1 to the power of 3 minus 7, 1 squared minus 27 times 1 minus 18. That's 1 plus 3 minus 7 minus 27 minus 18. I can already tell this is not headed in my direction here. Oh, let's use a calculator. 1 plus 3 minus 7 minus 27 minus 18 is so far off. Incorrect. Okay, let's try negative 1. Okay, negative 1 to the 4 will be 1. Negative 1 to the 3 will be negative 1 times 3 will be negative 3. Negative 1 squared will be positive 1 times negative 7 will be negative 7. Negative 27 times negative 1 will be positive 27, and then I still have a minus 18. This looks more promising. Let's see. 1 minus 3 minus 7 plus 27. Aha! Minus 18. 0. Yay! So our factor is going to be x plus 1. Remember, the opposite of the number that we checked. Okay, now we divide. And in the interest of space, I'll divide over here. Why not? We set up our little table. No, let's do it down here. There's space. So I'm checking negative 1, and I have coefficients are 1, 3, negative 7, negative 27, negative 18. Okay. Drop down the 1. Multiply across. Add down. Multiply across. Add down. Multiply across. Add down. Multiply across. Add down. Yay, we got 0. All good. Okay, so our factored form here, after all of this, is we have an x plus 1, x cubed plus 2x squared minus 9x minus 18. Okay, we are not done yet though. We need to factor this quotient. That's what's got to come next. We need this in fully factored form. Okay, so let's start again. Let's find some possible p-values. Actually, they're the same because it's still 18, so I can use all my possible p-values from before. Okay, and let's check against this guy. I'll do this in orange. Set it equal to f of x. Let's try 1. And I'm just, you know what? I'm not going to try one because this is going to take so long. I'm going to play the cards because I know the answer here, and the answer is 3. 3 is the number that works. You should be showing that you were checking, even if you just write it out once and then write what the remainder is. You should be showing that you're checking, but I'm going to jump right to the solution, which in this case is 3. That's what's going to work. Okay, so let's go, and I'm going to section off my work here. And let's actually do our division once again. Ooh. Come on over here. And I'll set it up, do this in pink. So 3 was the factor, and I'm factoring, or the divisor, and I had a 1, a 2, -9, and -18. Okay, let's do that synthetic division. Drop it down. Multiply across. Add down. Multiply across. Add down. Multiply across. Perfect. Got a 0. Awesome. Okay, so this is now, from here, these last 3, I have an x squared plus 5x plus 6. That is the factored form. Times, and then we'll do our divisor. Our divisor was x minus 3. Okay, so where we're at right now in this question is we had our initial function, x to the 4 plus 3x cubed minus 7x squared minus 27x minus 18. And we confirmed that initially x plus 1 was a divisor. And then we confirmed that x minus 3 was a divisor. And then we had this leftovers. Okay, and now we've hit a quadratic, and so we can think to ourselves, okay, is there any way that we can factor this, 2 numbers that add to 5 and multiply to 6? The answer is yes. The answer is 2 and 3. So I'm going to go ahead and factor that again to get our fully factored form. So I'll have an x plus 2, and I'll have an x plus 3. And that is our fully factored form. Yay! At the end of the day. Okay? This is like the more, I'm not going to say necessarily difficult question to do. It's just laborious, right? There's a lot of work that you've got to do, a lot of guessing and checking. I was able to skip because I sort of knew the answer in determining our second divisor, but that would be something that you have to check as well. So this is a question that I know would take quite some time for students to complete. Cognitively, it's not too challenging. You really just have to sort of remember the steps. Okay, so the first 3 examples that we've done have all been examples where the leading coefficient of the initial question is 1. There was a 1 right there. That's nice and easy. But of course, we can't keep it that easy. We are going to go down and try now a question where the leading coefficient is not 1. Okay, so here's our example. 3x cubed minus 19x squared plus 27x minus 7. Okay? What's going to happen here, what's going to be different, is the form of our factors. Factors are going to take this form, x minus p over q. P is going to be our constant term. So in this case, our constant term is -7. Okay, so I'm just going to write out possible p-values. Factors of 7 are only 1 and 7, plus minus, plus minus. Q, on the other hand, Q is our leading coefficient. And so in this case, that's 3. So possible Q values. Well, factors of 3 are 1 and 3. Plus, minus, plus, minus. Now what we have to do is we are literally going to list all of the different P over Q values. Okay? So we know that Q could be 4 different things. 1, 3, -1, -3. And it could have 4 possible numerators. 1, 7, -1, -7. So there's going to be a lot of combinations here. Literally, I'm just going to list them all out. Okay? It could be, let's start with denominators. I said there's 4 of each. -1, -1, 7, -7, 1, -1, 7, -7, 1, -1, 7, -7, 1, -1, 7, -7. I knew there were 4 options for each denominator because I had 2 possible p-values and they were both plus minus. I knew that there were 4 denominators because I had 2 numbers, 2 possible q values, 1 plus, 1 minus. Now, we've got a lot of redundancy here, and so we're literally just going to scratch off everything that's redundant. -1 divided by -1 is +1, and we've already got that here, so I'm just going to scratch that off. The negative sign on a fraction doesn't make a difference, so I'm going to scratch this one off, this one off. -7 over -1 is the same thing as 7 over 1, so I can also scratch that one off. And I'm going to do sort of the same thing for my denominators of 3. Where the negative sign goes doesn't make a difference, so I can ignore this one, just like I can ignore this one. And my -1 over -3 is the same thing as 1 over 3. Scratch that off. -7 over -3 is the same thing as +7 over +3, so I can scratch that off. And so let's simplify here, okay? There's a bunch of different options. I can say P over Q could be. It could be the number 1, both positive or negative. It could be the number 7, both positive or negative. In terms of fractions, it could be 1 over 3, again, both positive or negative. Or it could be 7 over 3, again, both positive or negative. So at the end of the day, we have 8. 8 total options. 2 are whole numbers, 2 are fractions that we have to deal with. My advice to you is always to start with the smallest one first, and hint, hint, that's the one that's going to work. In this case, our smallest one is 1 over 3, so let's check it. F of x, where is my function? There it is. 3. Sorry, I should write f of 1 over 3. 3 times 1 over 3 cubed minus 19 times 1 over 3 squared plus 27 times 1 over 3 minus 7. Okay, let's do that math. 1 over 3 cubed is 1 over 27. 1 over 3 squared is 1 over 9. 27 times 1 over 3 is just 9. I'll leave that though till our next line when we do all those multiplications. 3 times 1 over 27, well, these two help me cancel out and I get 1 over 9. Then I end up with just a 19 over 9. 27 times a third, I already said, is 9. Take away 7. 1 minus 19 over 9 is negative 18 over 9. And then positive 9 take away 7 is 2. Negative 18 over 9 is negative 2. So our answer is 0. Okay? If 1 over 3 hadn't worked, you would have checked negative 1 over 3 and then 1, and then go through your fractions a little bit more. We now know our divisor is x minus 1 over 3. Okay? Okay. Now we need to divide. Let's go ahead and do that. I'll do it in purple. Be consistent. Purple. There we go. Our factors, 1 over 3. Our coefficients are 3, 19, 27, negative 7. Nothing changes just because the divisor is a fraction. Literally nothing. Follow the same steps as before. Bring the 3 down. Multiply across. 3 times a third is 1. This should be negative. Add down. Negative 18. Multiply across. Negative 18 times a third is negative 6. Add down. 27 plus negative 6 is 21. Multiply across. 27 times a third is 7. Oh, look, negative 7 plus 7 is 0. Yay! Okay, so we know now we can write this in factored form. Let me do this in green. We have an x minus 1 over 3. And here we have 3x squared minus 18x plus 21. That's the factored form. We have to ask ourselves, can I factor further? Well, I can common factor. That's an easy one. Don't overcomplicate yourselves. I'm sure many of you were like, well, it's a complex trinomial. Look at that 3 up front, so I got to do that. No. Make your life easier. We'll factor out a 3. I'm going to put that right at the very front. And I'm left with an x squared minus 6x plus 7. Can I factor this further? No. We are done. There's no two numbers that add to negative 6 and multiply to positive 7. So we're done. Okay? Just to clean things up a little bit, what I'm actually going to do is I am going to distribute this coefficient of 3 into the brackets here to try and get rid of this fraction, because no one likes fractions, let's be honest with ourselves. I'm going to multiply it in. That'll get rid of that fraction. It'll clean it up nicely. It's not wrong. If you were to leave it like this, the 3 out front and then the fraction in the brackets, that's totally fine. You get full marks for that. No stress. I'm just doing it to clean it up. 3 times x will be 3x. 3 times negative a third will be negative 1. Okay, and I believe I'm correct in saying that anytime you're dealing with a question like this, or I should just say keep an eye out when you've got a question like this where the leading coefficient isn't 1, because you might be able to do that at the end to bring a number in and sort of clean things up. Okay, so I'll just write a concluding statement there. I'm just gonna say the fully factored form is 3x minus 1 times x squared minus 6x plus 7. Okay? And that's your factor theorem. Okay? Do some practice now where the coefficient is 1, arguably easier, and do some practice where the coefficient is not 1, just so you get the hang of listing out all those different options and checking them through. Good luck!